In this section, we're going to take a deeper dive into the adrenal glands. We're going to look at both what composes the cortex, the outer layers of it, compared to the medulla, the inner parts. So the adrenal glands lie on top of the kidneys, so they're also called the suprarenal glands because they're above it. And there are three main sections or portions that make up this adrenal gland. The outside is a covering called the renal caps or the adrenal capsule. It's just made up of dense irregular CT. It's not really going to have a role in any of our hormones, but just to let you know that it's there and it's making this an organ of itself. Then we've got the adrenal cortex, which is the outer part, and that adrenal cortex is made up of three different layers or regions that we're going to look at a lot more closely. That's the zona glomerulosa, the zona fasciculata, and the zona reticularis. And then deep inside is going to be the medulla, which you've already heard a little bit about with the sympathetic nervous system. The medulla, you'll remember, produces two hormones, those being epinephrine and norepinephrine. And we're going to take a look at that a little bit more in just a second. Okay, so if we blow that picture up and we say we're just going to concentrate on this outer region here, this adrenal cortex, that adrenal cortex, I said, is divided up into three different regions. And they all begin with this word zona. And zona just means belt. So you can think of it like a little belt around each part of the adrenal cortex. This first region we call the zona glomerulosa. And glomerulo or glomerulosa really just means little balls. And if you look at these in this region up here, it looks like these cells just make a bunch of little balls the way that they're all stacked together. This zona glomerulosa is going to secrete our mineral corticoids. Those are going to be dealing with salts. And the main mineral corticoid is going to be aldosterone. What aldosterone is going to do is it's actually going to pull salts back into our bloodstream and cause us to increase our blood volume because water is going to follow that salt. If you remember that for physiology, water always follows the salts, you're going to be halfway home. So remember that little saying, water always follows the salts. So aldosterone pulls salts into our blood and it's going to increase the blood volume because water is going to follow that. So that's the zona glomerulosa. The next layer is called the zona fasciculata. And fascicules or fascicles are little bundles. And if you look at the cells in this region here, you can see how they make little bundles. And in this region, this is going to be very important for secreting glucocorticoids. So glucocorticoids, the prominent one there is cortisol. And cortisol is going to be really important for, one, reducing inflammation. So it's actually going to inhibit your immune system a little bit, an inflammatory system, but it's also going to be important for managing stress. And the more cortisol that you have in your system is an indicator that your body is under a lot of stress. And traditionally, especially with the fight or flight whole mechanisms, you would only be getting little jolts of stress. And our body really isn't made to handle prolonged chronic periods of stress, and which we're seeing these days, both in this COVID environment and just with increased pressures of work and school and psychological kind of stresses. All of those are going to increase your cortisol. And while your cortisol is helping to deal with the stress, it's also going to reduce your immune system's ability to respond. And that's one reason why people who are stressed out more tend to get sick a lot easier, because their immune system isn't working as well. So another reason to take care of yourself. This zona fasciculata then, important for cortisol and other gluconeogenesis. So gluconeogenesis is making more sugar, and you make sugar out of things that aren't sugar, so glucose specifically. And you need that when you're in this fight or flight kind of situation, because you're going to need a little jolt of sugar so that you can use that energy. It's also going to help break down fats so that you can use those fats for energy. So all these things are coming from glucocorticoids made in this zona fasciculata. This third and deepest layer is called the zona reticularis. And reticule means network. So you're going to see kind of more of a network of these cells down here in this deeper layer. And it's in here that we're going to be producing androgens. And androgens are the sex hormones. Testosterone is an androgen. It's made in the testes. In the adrenal cortex, we're going to see weaker types of male sex hormones that are being made, but they're sex hormones just the same. So that takes care of the adrenal cortex. I like to think of the adrenal cortex, the way I can keep these things organized in my head is I think of the 3 S's for the adrenal cortex. And those 3 S's are going to be salts up here, stress in the middle, and sex down in the bottom. Salt, stress, and sex. Salt for aldosterone, stress for the cortisol, and sex for the male sex hormones. That's going to be taking care of our adrenal cortex. Then we get down into the adrenal medulla, and that's going to be this middle section in here, and we're going to look at that next. So if you think about the adrenal gland, here's our cortex on the outside. Now I'm kind of emphasizing the adrenal medulla inside. That adrenal medulla, you'll recall, is a modified sympathetic ganglion of the sympathetic nervous system. So it's not that sympathetic or that paravertebral chain ganglion. It's kind of its own separate thing. It's not one of the prevertebral ganglion. It's its own modified ganglion. And in it, it's going to have all these little chromaffin cells. And you can think of these chromaffin cells as being modified postganglionic neurons. You're going to have your preganglionic sympathetic neurons coming in here. This is going to be from probably the lower part of that T1 to L2 complex in the spinal cord. You're going to have these guys coming in here, and they're going to be synapsing on chromaffin cells. And those chromaffin cells, the reason why they're modified is that they don't have any axons coming out, if you notice that. They're just cells. So they're going to be making epinephrine and norepinephrine. And primarily, they're making epinephrine. About 80% of what they make is epinephrine. These are called sympathomimetics. They're going to basically be mimicking what's going on in the rest of the sympathetic nervous system, and then getting that fight or flight action going. So primarily epinephrine coming out of here, and it's going to be sending a big boatload of that into your blood supply, and that's going to go throughout your body, as opposed to those the nerves that are going to the preganglionic nerves or the postganglionic nerves to their specific organ. That's going to produce more of a localized effect. This adrenal medulla is going to be going to all parts of your body because it's going into your bloodstream at large. So it's going to help to reduce stress, very similar to the glucocorticoids that we saw in the adrenal cortex. But unlike the adrenal cortex, it's not essential for life, unless you're running away from that scary lion, tiger, or bear. But for everyday life processes, you don't need to have this epinephrine and norepinephrine being secreted out all the time. Okay, so this slide kind of puts it all together here. We've got our adrenal gland, and we've got the outside here. We've got our cortex made up of that zona glomerulosa. We've got the zona fasciculata in the middle, and the zona reticularis deep. And between the three of those, we're going to be managing our salts as mineral corticoids in this glomerulosa. We're going to be managing stress with the glucocorticoids, the cortisol, in this fasciculata. And we're going to manage androgens, or the sex steroids, with zona reticularis. And then deep down in the medulla, you're going to have the catecholamines, which are epinephrine and norepinephrine, doing our fight or flight response.